recording this, which means that you guys specifically are going to be in trouble for this. So,
Wait, we have to be quiet.
that's a stretch. So, ladies and gentlemen, now's the time. Ladies and gentlemen, there we go. So we're doing this a little bit as a bit of a practice and kind of see what this kind of stuff looks like and feels like. We're kind of running through the varieties of different stuff that we do in a class. So typically when I do any sort of notes or review or whatever, this is usually where I stand, is kind of up in this zone. This is the webcam, this thing right here. So I do use that to record. So I'm live streaming it right now. Huge on the internet, not. But the reason why I always do this stuff, and I've been doing this for years at this point, is so that if someone is excluded, if they're sick, if they're out for baseball, if they're traveling, if they've got Rona, whatever, that I will still continue to, when we do these sorts of labs, kind of just very low key record these things. That way, if there's a record of what's going on, you can go look back at it later if you want to check notes or something like that. But I do try to do it pretty regularly. So more than anything today, I'm just kind of testing the equipment to see what the sound is like and all of that kind of good stuff. Y'all need to know that you are in school and you're driving me insane. Thank you. Remember, I am currently your boss. You should be acting like you care. No, you're fine. You're totally fine. But this is the time to stop messing with stuff and start taking notes. So notebooks open, pencils, calculators. That's how that works. When I'm standing here addressing the class, that's what that means. You guys have been in school for 10 years. You know better by now. So anyway, like I said, I do record it. It is kind of there to that. You know that's soap, right? Yeah. Okay, just making sure. Someone thought that was hand sanitizer. God, it won't go away. No. Okay. So we did molar mass. We did this actually last week. So I'm gonna do the quick review on this stuff because I know that this is one of those things that is confusing for students. And once it clicks, it's not so bad. But it is kind of confusing for students, at least at first. Second thing to know is, yes, I do want you to do dimensional analysis with this, something like that, Zerlunda fraction, so that you can get used to that style. We keep building on this skill. It's back there. Still, you got it all the way back there, right? So it's a skill that we keep building on. Dimensional analysis, this style, is actually really, really useful, especially when you don't know what the units are. Do I multiply? Do I divide? When do I use the numbers? All of that kind of stuff. That's why we kind of teach this strategy. You guys had this in math class. It's the other reason why we use that in here, because it connects to something that you already learned. So when we're doing problems like this, remember we've got 2 and only 2 conversions. Only 2. Supposed to 12 inches equals a foot, and 3 feet equals a mile, and whatever else is going on. 3 feet equals a yard. We've only got 2 conversions. So number 1, Avogadro's number. Oh, wait, there you go. 0.22 times 10 to the 23rd things. Yeah. And I'm just going to put things up there for now because, yeah, it is typically atoms. In a chemistry class, that's typically what we are going to use. But it's anything, just like a dozen can be anything, right? That's what a dozen means. It could be a dozen puppies. Oh. It could be a dozen donuts. Could be a dozen pieces of homework, or I don't know, whatever it is. So a dozen things, whatever equals a mole. What's the typical things that we're using in chemistry? Yeah, this one. Atoms, right? I'm also doing this so you get used to what my handwriting looks like. Yeah, wow. Get over it. Burn. Burn. Stella is. Salty. Oh! All right. Messy, my handwriting. All right, so, yeah, I know my handwriting. I've gotten used to yours. Get over it. Oh, my feelings are not. So 6.022 times 10 to the 23rd things equals a mole. Again, typically the things that we are to are atoms, but starting like tomorrow or whatever we do this next, it can also be this. And that's what we got to be a little careful with. Molecules. So when we're dealing with compounds, the 6.022, whatever, is molecules equals a mole. When we're just talking about elements, it's atoms equals a mole. Just like a dozen things Is it a dozen single things or a dozen multiple things? I know it sounds funny, but is it a dozen pieces of bread or is it a dozen sandwiches? Right? Sandwiches are a compound item. Molecules are a compound item, but we treat that compound item like a unit. When you talk about a sandwich, it's got a whole bunch of stuff in it, I hope. Little, if you're eating a piece of bread with butter on it, that is not a sandwich. Okay? So, we will get there. This thing, this conversion, is known as Avogadro's number. Avogadro's number, exactly. Again, this is just the name that we use for this conversion because it's just easier to talk about it that way. This is called Avogadro's number. Again, he was the guy that figured out what this was, Calm. He was the guy that figured out what this was, so we just named it after him. So Avogadro's number is a great way to just remember it. I'm not going to mark you wrong. A lot of times I just write it like that. Avogadro, Avogadro, is actually how you spell the guy's name. So Avogadro's number, that many things equals a mole. We have a second conversion too. This is the one that's harder to write. This is the one that kind of gets people a little wobbly on it. So the second one has to do with mass. So a certain number of grams can also be equal to a mole. Where do we get the grams from? No, that's here. Yeah, when we're talking about grams, though, masses, we get this from PT. This is the average atomic mass in grams. So this thing right here is the PT. Whatever you want to call that, periodic table is what PT stands for. The name of this is called molar mass. Oops, I'll get spelled. M-O-L-A-R. Hold on. Okay. So this, we have to be a little bit careful because it depends on which element we're talking about. Some elements are heavier, some elements are lighter. So this is from the periodic table number of grams. And again, when we're talking about periodic table, we're talking about like the little values that's up here. Or if you're talking about on that one, that big periodic table, if there's the number that's on the bottom, that average atomic mass, the decimal place number, is the one that goes in there. So if I want to know what the molar mass of titanium is, I have to go find titanium on the periodic table, do your scavenger hunt, go look it up. Molar mass of titanium is 47 point, I think that's an 867. Number 22? Number 22? My eyes are not very good, so.
They seem pretty good.
Yeah, I'm squinting. It's okay. 867. Plus I practice. So I would say 47.867 grams of titanium equals 1 mole of titanium. So you got to look up on the periodic table. Remember, I've given you guys periodic tables. Yeah, you'll need to use them a lot. If you need an extra one, they're up here. So there's periodic tables up there if you need them. Now you know where they are. So, for example, this is for the standard. This is how the standard is worded, like the practice problems on the standard. This is an example of what this looks like. As soon as I come, like, I don't have the molar mass, the molar quantities lab, and I don't have a textbook. How do I do this? You don't need either of them. So this is written like a sentence stem, like fill in the blank. You pick an element and you pick a number. And you rip things, apparently. So, that's totally fine. That's totally fine. So, what do we want for our element Y? Someone pick an element. Potassium it is, I heard it. That's literally it. In the standard, pick an element, close your eyes and point. You don't need the molar mass lab. The one time you actually follow directions. You don't have to, you don't need a book, you don't need anything fancy. You did perfect. No, you did great. You just pick an element. Okay, potassium, great. Now pick a number. 37 point what? 37.242. I heard a 5 in there somewhere too, so there we go. Whatever. Pick a number. That's it. I got it. I already did.
Are we close?
No, you're not close. Hold on.
Oh, this brings me back to the chicken and
I gotta change this. I messed it up. There you go. I need 2 different units in there. I changed the word up there, by the way. I realized I had it written wrong up there. I changed the unit of the 37 to moles. I had grams originally written there, so fix yours. Fix yours in your notebook. I originally, if you had copied this off the board, I had written the word grams here. Turn it to moles. It'll make more sense for the... Well, it's a good idea. Really, child? I just changed the word grams to the word moles. That is the only change I made. So fix that in your notes if you wrote it down. I know, right? And y'all can't handle it. So should you be writing this down? Yeah. Interesting how it's backwards. Yeah. So normally, you've already done this part at home, right? You've taken notes on it. You should have already done some of that. So we're working on a practice problem is what we're actually doing. This isn't really notes the same way. Problem to solve. How many grams of potassium are in 37.245? Did I read that right? 245 moles of potassium. I'll remind you guys, I am mildly dyslexic, so if I say something wrong, numbers, if I get them backwards, just let me know. I'm pretty good at catching it after all these years, but if I'm putting something up here that you're like, Ms. B, that's not what that says, just tell me. I'm used to that. You're not going to embarrass me. Well, you might embarrass yourselves, but not me. So anyway, there we go. So how do we solve this? Not yet.
Molar mass.
Not yet.
Table.
Make a Wunderfraction fraction. Table. Yeah, dimensional analysis. Where do we start? Yeah.
You start with the first unit on top.
Yeah, start with the first unit that you're given. You put it on top. Start. Write it down. Go figure it out. 37.245.
Did you just make up the 37?
Somebody said.
Oh, it was me, but I didn't know.
Yeah.
I didn't know if you were actually looking for a number, and I didn't.
Nope, it was fine.
I literally said 37.
Okay, important step for all you guys. Okay, this is one of those things that students always want to shortcut this, and they just want to do the math, and they don't want to set it up. Don't. It will actually save you time to write the units and labels in there because it helps you set up the problem rather than doing it wrong and having to go back and do it again. Take the extra literally 0.1 second of effort that it takes to write the letters M-O-L-E-K. Seriously, you're freaking lazy if you can't actually write 5 letters. You literally end up wasting more of your own time. So, number 1, start with that. Why do we start there? Because that's what was given to you in the problem. Step number 2. Yeah, make your Wunderfraction. Yeah. Yeah. We have to have some Wunderfraction. Yeah. Wow. Is he always like this? He is, isn't he? Dane Bramage. Drugs, not even once.
Whoa.
Remember, I'm recording. Remember, I'm recording.
Albuterol for my
Asthma. So in our next step, moles got to cross on the bottom. So again, if you're struggling with this, I'm talking to you right now. The unit crosses down.
Are you talking about moles?
No, the element potassium. No, great question. Thank you. Calm. This is not the time. So there's a time to goof around and talk a whole bunch and have fun. This isn't it because let us work through this. Otherwise, it ends up just being painful. I know, right? Poor guy. So if you're struggling with stuff, the unit is where you start. You literally take whatever this unit is and put it in the bottom of the next step. Moles of K. The most difficult thing that students have is they don't know where to go next. Like they can start it and then they're like, then what? And when you're doing it on your own, they just kind of get lost. They're not sure where to go from. So you right now, all of you guys, if this is not obvious to you, and you know who you are, if this is not obvious to you, make yourself a note of why you did that. You all know what happens in math class when you take notes on math, right? And then you come back to it the next day and you're like, where the F did this number come from? Everybody does that. Annotate your notes. Say, why did you put moles down here? Just make sure, cross down. Don't do it for me, do it for yourself. I don't care what you take for notes, but make yourself notes that are useful. Do we have a conversion that goes from moles to something that we want?
Atomic
Yeah.
mass.
We've got two different conversions. We've got molar mass or atomic mass, and we've got avocado's number. Which one do we want to use here?
Atomic mass.
If we want to go to grams, then that's the unit that we want to put on top if we can. Is there a conversion that does this? Yeah. That's the atomic mass one.
Yes, I knew it.
And it's grams of potassium, grams of K.
Potassium K.
Potassium is K, yeah.
Is that it on the periodic?
Number 19 on the left side. So now when you're filling these in, in conversions, it's always 1 mole whenever we do conversions. And then what goes up here with grams?
Molar mass.
Atomic mass, molar mass goes up here. So find on the periodic table, it's number 19.
Oh,
That's not the number 19 goes here, but it's atom number 19.
39.098.
098 something or other. 0983. It's tiny on that one. It's hard to see it. It's right here. 098 right there. That one has the extra digit on it. By the way, for the purposes of what we are doing in Chem 1, 2 decimal places is plenty. Don't round it more than that, but 2 decimal places is fine for molar masses. So writing this as 39 point, well, you can't just write it as 09 because this rounds up. So writing as 39.10 would be fine. But don't just write it as 39. 2 decimal places is kind of a generic rule. So it's like, oh God, do I have to write all these decimal places? 2 decimal places.
You just put 1 0.
Yeah, because 9 rounds to...
Yeah, that works. Those are the same value. Close enough with sig figs. That works as well. Again, if you're not sure where that came from, if this is not easy for you, write where you got this number. Make yourself that annotation from PT or whatever makes sense to you. Again, you're not taking notes for me. As you guys are getting ready to transition towards college level learning, you got to take notes that give you the information you need. That's the key part. Now what? Yeah. These are not complete. They're not sufficient. This is more of a practice problem. You can add your notes from Standard 6A to this, but we're just literally doing an example problem for here. Just doing it slow. It's pretty close. All right, now what? Are we done?
No.
We haven't solved any.
Are we done with the Wunderfraction?
No, it's not.
Do we need another step? Yeah. Okay, check your units. The last unit here is grams. Our question is asking us for grams. So we're done with the setup part. So now we do the calculator part. Multiply across the top, divide on the bottom. So this is just multiplication. But this is how you know it's the multiplication and not division.
So, when would it be a division problem?
The number's on the bottom. If you have a number that's not 1 on the bottom, then it's a division
What's
problem.
an example of when
If I start with grams and I'm converting to moles.
And then you're getting it to moles, but we're going to moles to grams, so it's multiplication.
Yep.
And then how would I...
Math.
Oh,
Calculator, go.
how would I know if the grams on the top or the bottom?
Follow your units. The units determine which one you do. So you follow that down, grams ends up on top now. So
Because then if you went from grams, moles would be down there.
follow the units. Calculator, figure it out. It's a big number. It's a big number. 37.245 times 39.0983. Okay, so 1456.21684. There we go. Yay. Okay, last bit. So this is what, if I calculate it out, I didn't use the rounded answer. If I calculate it out, so calculator says multiply across the top, big number, sig figs and units required in answers for math. So or chemistry, math. So sig figs and unit. What kind of sig figs do we have in this problem?
What is 2?
Try again.
3.
Try again. Look at your original value. There's it is. 5. We got 5 digits to work with. You look at your original problem. Okay, hold on. Stop. Listen for a sec. Wait. Okay. When you're doing sig figs, always look at the problem, not your conversions. I could have written these conversions with any number of sig figs that I wanted to. Same thing with Avogadro's number, 6.022. There's more decimal places. We just stopped. So always look at the problem for sig figs. Don't look at what you're doing ends of unit fraction. Yeah. So 5 digits. 1, 2, 3, 4, and there's our 5th digits right there, the 2. So do I round up or round down? I have to look at the stuff after. That's a round down. So 1, 4, 5, 6.2. And then what's our units? Of what? Grams of potassium. Grams potassium. Okay, I'm going to do another one. We're going to do it faster. So, and then you got to do it on your own. I know, I hate you too.
Okay, wait, so I had a quick question. So you just look at the first number and it's how many numbers are in it. It's not how many numbers after.
No, correct. It's how many digits total are in it.
Oh, okay.
It's not the decimal places. Great question. All right. Here's one for you. This is going to be 2 steps, so it's going to be a little bit longer than the last one. So we need, we're going to have to do X grams of Y. Again, these are still similar to how these are worded in the standard. No, you cannot use this example for the standard because it's my work, not yours. The steps are the same. You just plug in different numbers. Same idea. I need a number.
Oh, 227.46.
Okay, there you go. 27.46 grams. Need a different element. Lithium, I heard it. There we go. Lithium. Pick an element, pick a number. And now you just do the math that's on there. So 27.46 grams of lithium is the one we will do. This is a 2-step problem. So start it off with what you know, 27.46 grams of lithium.
Dividing. Same as last one.
Follow your units. Take a moment and take a risk. Look at your units. See if you can get it set up. And I'll come around and help you guys. See if you can get this one set up. Follow your units. We only have 2 conversions to use. You will use both of them in this problem. But take a moment, okay? Cross down your units. What can you convert it to? Lithium is 6.94. 1. 941. Depends on which periodic table you look at. 94 is fine.
Okay.
94 is fine. Because of 2 decimal places, yeah. That's pretty common. So you guys should be writing. Take a risk. Put yourself in the spot. Follow the units. Try to do the cross down part. If you're stuck, work with a partner. But until you make yourself uncomfortable, you won't get comfortable.
I can't find the mold.
So this is grams. So this has to be grams.
Oh,
Right? You got to flip-flop that step.
I got you. And then we cross.
Yeah, but you have to flip the numbers. You can't just change the unit without moving this number down there. Molar mass equals 1 mole. If this is grams, molar mass needs to be on the bottom of the next step.
Okay.
Okay? Yeah, you can restart. There you go. You got it? How are we doing? I'm wandering. Got a thought? Lithium's on the top left.
Okay.
Yeah, lithium's top left. Nicole, how are you doing? Which part?
Well, see, I got this down.
Right.
I don't know what to put here.
So same unit goes down here.
Okay.
So not a number, just put the unit, grams of lithium. Okay, so now we only have 2 conversions that we can use. Which one has grams in it?
Oh,
This is the only one that you've got. So that means your periodic table mass goes here and 1 mole goes on the top.
okay.
There you go.
Did I do it right?
So far so good. Yeah, and then just keep going. Okay. Questions? What do we got? Got a plan? Remember the molar. These won't be the same. Look at your conversion. Where is it? Periodic table mass in grams equals 1 mole. Not 1 gram equals 6.94 grams. You're close. Super close. Okay. What? Take a look at where this is. Where's your conversions that we had? Oh, you didn't write. You didn't take notes on the other part, did we? Okay. So remember, molar mass always goes with grams. You've got these two numbers flip-flopped. That number from the periodic table always goes with the unit grams, and 1 goes with the unit moles, basically, is what's going to go up there. You just didn't get the conversions from earlier.
You're still broken.
Yeah, it's okay. It's okay. Okay, hold on. You're trying to skip too many steps. You don't have notes on this from earlier either, huh?
Follow Derek.
That's okay. Look at the notes from earlier. It's okay. I'm going to put this back up here. Those are the only 2 conversions that we've got. No. Right there. Grab some moles to atoms. Yep.
I can't make it go sideways.
Turn off your screen lock.
Do I put the conversion? I have 6 grams on the bottom,
Uh-huh.
right? And then do I put moles on the top?
Yep, 'cause that's the
Is
molar
that
mass one.
Conversion. Do I do?
Is this what it's supposed to look like?
Avocado's number right
No,
here?
no, you do moles. Grams to moles. Then you're going to do a second step that's got avocado's
But
number in
what
there.
is gram?
Equals 1 mole. That many periodic table grams equals 1 mole. That many grams equals on the top 1 mole.
So no matter what it is, it just equals 1 mole.
When you're doing the conversions.
All
Yep,
right,
you got
thank you.
You got it. Don't forget to put your units in there. You're on the right track. Yeah, you're on the right track. Grams to moles, moles to atoms. Perfect. Yeah. What are we doing? Pain.
Huh?
Pain.
Pain.
Struggling. Andy, you love math. I know you do. So this is correct. So you've got grams here. You've got the molar mass equals 1 mole. So this is moles. That's your final unit of that, moles. Okay, which is fine. Now you're not done yet. You got to do one more step because the question asks for atoms. So do one more little mini wonder fraction. You're almost there. You're skipping the step. Hold on. This is not moles. Wait. I take it back. Never mind. You're right on. You're right on. Nope, you're there. I didn't realize you had it in two problems. That's totally on me. How are we doing? Yeah? You got grams to moles, moles to atoms. Perfect. Yeah, you can do this 2 steps. You got it? Yeah, nice. What? I'm coming around.
You guys stuck.
Okay.
Right there.
So this is where you get your units are funky. Look at your units up in here. It's periodic table grams equals 1 mole. Periodic table grams equals 1 mole.
Oh, okay.
Okay. So again, it's up here. This one right here. Periodic table grams equals 1 mole. It's just called molar mass. It's not divided by molar mass. Okay. So if you have the periodic table grams here, because grams is here, cross it down, you convert to moles up on the top. Does that help?
Yeah.
Okay. Grams to moles. This is close. It's just upside down. You're using this one now. So if moles is here, and then atoms is on the top.
So this is atoms.
That number goes with the word atoms, yes. It should be up on the top.
Okay.
Yep. Now you're super close. Grams equals 1 mole. Yeah, perfect. Yes, one more step. You're there. No, you're there. This is why we do this all together. How are we doing?
I don't know.
That step was correct. It's always 1. Periodic table grams equals 1 mole. So this is always 1 here.
Okay.
And then you got one more step.
Well, I already did the conversion from the periodic table to
Yep.
moles.
You have grams to moles.
So can I just go moles to
So
moles?
moles to atoms is that second step.
But this is 1.
This
so
is
I
going to be
just
1.
put
Yep. You just literally write 1 on the bottom again.
I didn't know you could do that.
Yep. Because they cancel each other out. Multiply by 1, divide by 1. How are we doing now?
Is that correct?
Grams to moles. That's correct. That's molar mass. And then moles to atoms.
But then, and the numbers.
And that's the avocado's number. Yep.
Avocado.
Avocado's number. There we go. I think I've visited most folks. This is upside down. This is not atoms. Okay, remember, you've got your conversions right here. That many things equals 1 mole, but if you're talking about grams, it's grams equals a mole. So this needs to be grams on the bottom. Yeah, well,
How many moles are in an atom?
okay. All right. Yeah, how many moles are in an atom? Yeah, not so much. How many atoms are in a mole? Okay. So, setting these up. Always when I set these up, I'm interested in how many people wrote this down from earlier. A lot of you guys wrote this. I see this divided by molar mass. Okay, so I'm gonna put something on you guys. I see this. Oh, I saw that. That's what I kept seeing. Please do not write this down. Please do not write this down. Please do not write this down. Listen to me for a second. No, don't, please, because this is incorrect. So here's what's happening. Stop and listen. Y'all are 10th and 11th graders and a senior. I didn't volunteer that. All right. So y'alls need to break one really particularly bad habit that you have developed in school from whatever reasons. You're literally copying from on the board like that's going to help without understanding it. So you're literally like, it would be like I might as well have just written in Chinese on the board. And you're just trying to make the shape in your notebook. Like that's somehow magically going to help you. Not everybody's doing this, and I'm aware of that. But a lot of people are doing this. You're literally just mimicking the shapes that I'm putting on the board as opposed to going, what does that mean? So please try. And if you're not sure what it means, ask. You guys haven't figured this out, that this is a pretty casual environment. We're okay with this, even with a lot of people. We can figure this stuff out. So this is just copied from the board to try to make it look like what I had on the board earlier, because that's literally what I'm seeing people copy without understanding what that means. This was a blank, which you fill in the number from the periodic table. It is not PT divided by molar mass. But I saw a lot of people copy that down and then read it back to me because you didn't actually understood what I wrote there earlier. So please make sure that you're asking with that stuff. It's fine, but make sure you're asking. So a lot of people did that. I literally just looked at people's notebooks and saw it. So be careful with that. Yeah, I know that too. So when we do a grams to moles conversion, grams is down here because I want those units to cancel out. Whenever we do a grams to moles conversion, this is called a molar mass step. This is called a molar mass step. The number does not go here. It does not go on top. It goes with the unit grams. Sometimes it's on the top, sometimes it's on the bottom. The molar mass from the periodic table goes with grams wherever grams is. That's the important part that some of you may want to write down, especially if you're the ones that are walking around going, oh, the 6.94 goes here because molar mass goes with the unit grams. Sometimes it's on the bottom, sometimes it's on the top. It depends. When you're doing a conversion like this, the mole is always 1 in the conversion. Okay, everyone look out the window. What is it? Milk truck, I don't know. Okay, step number 2. I put moles on the bottom so that it would cancel out. And now I can convert from moles to atoms because that's what the question asked you for.
So now you divide.
Not yet. But you're close. No, you're close. This is called Avogadro's number. Whenever we've got avocados going on here, atoms and moles, this is where we use Avogadro's number. Does Avogadro's number go with atoms or does it go with moles? Is it 6.022 times 10 to the 23rd moles equals 1 atom, or atoms equals 1 mole, right? So make sure you look at your notes. That goes here. Goes there. Again, use the frameworks of Wunderfraction to set up the units and then plug in the numbers where the numbers go. You kind of expect the numbers to go in one spot. They don't. They move around depending on which way the problem is going. Sometimes we're going from grams to atoms. Sometimes we're going from atoms to grams. So you can't just predict whether you're multiplying or dividing. Now do the math. and actually figure out what the answer is. Make sure that you're using your calculator correctly. This one should be a big number. Mm-hmm.
So
190 Schrodinger's superposition then and alive. Are you telling me that theoretically Aiden could be annoying and not annoying at the same time?
No, he's just annoying.
That's what I was
Yeah, no, just annoying, 100%.
In your physics class,
Some, it depends on the year. So like this year, not so much because it's been such a weird. I always put a little bit in there. I usually actually do some in this class too.
tell us our numbers right?
we might have done something. Nope, that is not.
Yeah, that's definitely what I saw.
Hold on, 27.46 times 6.022 times 10 to the 23rd divided by 6.94. No, that's it. That's it. That is it. Got to do some sig figs. Okay. Do you have the answer on your paper? Because you're amazing. I understand.
So smart. No, Chris,
Gravity search.
I got a random answer that is
That is,
strange.
that is exactly the correct answer. You just maybe rounded one of your digits a little different than mine. Because you used the one or the two there, and I didn't. That's all. It's the same answer.
Cool.
Yeah, you're fine.
So I'm smart.
Yep. No, I don't know that I agree with that. Shoot. Okay, what?
So to put this in here, I really have like trouble because I don't know.
Okay. You see how the EE is right here?
Yeah.
So you're going to do shift. E button. Just type the 23.
Oh.
That's it.
And then I hit enter.
Yep. And then you can do divided by the 6.941. Okay. All right. So we will do this at the beginning of class, apparently on Thursday, because we're a little bit on the slow side today, which is fine. That's what we're going to use the pellets for. I just want you to know that that's what they're there for. You're going to clean those up, right? Not put those on the floor? Of course. Okay, just making sure. Our custodian's overworked as it is. Poor guy. What?
I thought that was pretty scientific.
Nicely done. Little cone of. It is, but what did you think it was?
Sherry Bedwell.
It's not my first name.
Just kidding. It's Christy.
My first name's Barb. No.
Barb, yeah. What? Is your husband your name?
No.